Hi, I'm Abdul. This is my IBM Coursera Advanced Data Science Capstone Projects presentation. My project is about the prediction of election corruption in Africa using machine learning and deep learning. So for this presentation, I will firstly talk about my motivations, then I will present the data sets I used and my use case, and I will show you the implementation of my solution. As you may know, Transparency International published each year the Corruption Perception Index. So this index ranks countries around the world from 0 to 100. A value of 0 means that the country is very corrupted, while the value of 1000 means that the country is very clean. So here we can see that in Africa, a lot of countries are highly corrupted. So this is the Corruption Perception Index of 2018. So my question was, could we use machine learning and deep learning tools to better understand corruption in Africa? The data set I used is from the round 5 of AfroBarometer survey. AfroBarometer is a research network which is independent and which measures attitudes on political, economic and social matters in Africa. So the survey was conducted in from 2011 to 2013. There are about 17 topics from which we have experiences of paying bribes for services and so on. So the dimension of the data is 348 and the sample size is more than 50,000. The data types are numerical, categorical, and ordinal. So my use case is in which way machine learning and deep learning could help us to better understand corruption in Africa. It turns out that there were a question in the survey questionnaire which is the following, and which answers are the following. So I was interested in predicting this variable to see if an individual have ever experienced election corruption or not. So the solution, the models that I implemented in machine learning are these models: XGBoost, lightGBM, CatBoost, scikit-learn, and InterpretML. InterpretML is a package released by Microsoft a few weeks ago. For deep learning models, I implemented a sequential models with this architecture. So now let's see the implementation of my solution on Jupyter notebook. So here I'm reading my data. We have already seen the shape. In the first part, I was interested in knowing the percentage of the missing data. So here we can see that we have about 40 columns which have high missing data. So for my modeling, I will drop all these columns. After that, I define some helper functions to visualize my data. So here I'm visualizing the distribution. Sorry. Here I'm visualizing the age groups and the sex distribution. We can see that the sex is equally distributed, while it's not the case for the age groups. Then I visualize the distribution of education levels. And after that, I did a visualization on the most frequent type of corruption in Africa. So For instance, we can see that here in my hometown, Niger, the most frequent type of corruption at the period of the survey is election incentives. So it turns out that at this period, in 2011, there were an election in my country. So this result is not very surprising. So after that, I visualize the frequencies of the most frequent type of corruption. Uh, then I prepared my data for modeling. Before doing that, so I set my target variable. I fill the missing values with the modes, and I scaled my data. In the unsupervised learning, I performed a principal component analysis with two components. So I plotted the results using my target variable. So we can see that all the classes overlapped, and we can also note that the principal component is only able to capture 18% of the information of my original data. So this means that we lose more than 80% of the information of the original data. What I noticed is that we have some classes that are in this region. So what I did is to merge the classes, these classes once or twice, a few times, often, to be the class 1 and never the class 0. So after that, I performed a k-means clustering on the results of my principal component analysis. So before doing that, I did a Elbow criterion to determine the optimal number of my clusters. So from this figure, we can see that it's 4. So then I run the principal component analysis with 4 clusters, and I obtain these results. So here is the correlation circle of my principal component analysis. So it will help us to better interpret the results of my clusters and the principal component analysis. So for instance, we can see that here the urban zone, the x-axis oppose individuals that are in urban zone and individuals that are in rural zone. So after performing the k-means clustering, I was interested in comparing my clusters. So here I'm comparing my clusters based on the sex. So we can see that in clusters 2, we have the least number of women of male. So here I'm comparing based on the age. You can see that in cluster 1, the mean age is 36, while it's 40 in cluster 2. Then I compared my clusters based on the education, based on the countries, based on receiving bribe for election, based on paying bribe for document or permits, basing on paying bribe for water or sanitation services, based on paying bribe for treatment at local health clinic, and based on paying bribe to avoid problem with police and for school placements. So for my supervised learning, before performing the classification, so I did feature engineering. So I implemented count encoding and target encoding, which are the most common type of feature engineering of categorical data. So here are part of my data transform. Then I split it here my data into training and validation sets, and I performed my classification, my supervised learning models. Here we can see the different scores that I computed. We can see that the recall score for lightGBM and CatBoost are the best. So in our case, the accuracy is not a good score because our labels are highly imbalanced. And here I compute the execution time of each model. We can see that explainable boosting is the one taking the lot of time. And then I performed a semi-supervised learning. So in semi-supervised learning, we will use a part of our validation data and concatenate it to our training data. So this process could help us to improve the accuracy, the performance of our models. Unfortunately, it turns out that for some of my models, the performances decrease. For instance, for lightGBM, while for CatBoost, the performance does not change. So to sum up, my goal was to use machine learning and deep learning to predict corruption in Africa. So I used a data from AfroBarometer around 5 survey, and I implemented machine learning and deep learning models after performing the supervised and semi-supervised learning. Some of my model performances decrease while the performances of some other models do not change. So this is the end of my presentation. Thank you very much for your attention. If you have any questions, so please don't forget to comment this presentation. Thank you.